In this section, we're going to talk about writing equations of a linear function given 2 points on the line. Now we've done slope-intercept, where you're given the slope and the y-intercept. We've used point-slope, where you're given a point on the line, x1, y1, and the slope. And now we're going to use one where you're given 2 distinct points. There are some textbooks that use something called the 2-point form, but we've chosen not to do that. We're going to need, though, 2 of the tools from this little toolbox. We are going to need the actual slope formula, where you find the slope when you're given where you're given 2 points, and we're also then going to turn around and use the point slope form. So these problems will be 2-step problems. Let's take a look. All right, in the first problem, you are given 2 points. So if you are given 2 points, you're going to do 2 things. You're going to use the slope formula to calculate the slope, and then you're going to use point slope formula. And when you use the point slope formula, you get to choose which of the 2 points that you want to include in it. And it doesn't matter which one you use, you get the same equation. All right, so let's take a look. All right, we are given 2 points. Let me rewrite those. I have 2, 7, and I have 3, 12. One of them is point number 1, and one of them is point number 2. So I'm going to call this x1, y1, and I'm going to call this one x2, y2. And I hope you remember this from a previous class where you found the slope. The slope formula, at least the way I use it, I have the difference of the y's on top, difference of the x's on bottom. Slope is equal to y1 minus y2 over x1 minus x2. Certainly most textbooks actually put the 2's before the 1's. It makes no difference as long as you're consistent with the top and the bottom. So in ours, the slope is 7 minus 12. That's the difference in the y's, over 2 minus 3. So the way that I'm working it out, I get a -5 over a -1, which is 5. If you had chosen to do it the other way, you would get +5 over +1. It would still be 5. The second part of our problem is to now use point slope. And point slope is y minus y1 is equal to m times x minus x1. Now, I called this x1, y1, but it doesn't matter. You could choose either point. So I've got a point and the slope. You could have done it with this point and you would get the same results. All right? So I have y minus 7 is equal to 5, which is the calculated slope, times x minus 2. So I have y minus 7 is equal to distributive property, 5x minus 10. Add 7 because we need to get this, solve for y. And I have y is equal to 5x minus 3. The instructions said to use function notation. So in MathLab, it will say f of x is equal to, and you will fill in the other side of the function notation, and you'll put in the 5x minus 3. So just going back, the only line that goes through these 2 points is this linear function. All right, let's do it again. Let's get another set of points. All right, in this one, I have -1, 8, and I have -2, 13. Anytime you're given 2 points, It's a two-step problem. First, we need to find the slope. Find the slope of the line that goes through those 2 points. M is equal to y1 minus y2 over x1 minus x2. So, difference of the y's on top, difference of the x's on bottom. That's going to be 8 minus 13 over -1 minus -2. Be real careful when you have minus minus, because I think everybody remembers that becomes plus. So I have -5 over 1, which is -5. If this would be a fraction that doesn't result in an integer, then you just use a fraction. That's the slope. All right, so now use point slope. Y minus y1 is equal to m times x minus x1. All right, this time I choose this point, and I've calculated this slope. And it does not matter which point you choose. So I have y minus 8 is equal to -5 times x minus -1. So y minus 8 is equal to, minus minus was plus, distributive property, that's -5x minus 5. Add 8 to both sides, and y is equal to -5x plus 3. And this entire statement is the linear function. It is the line that goes through these 2 points. All right, let's do just one more. Oops. All right, let's find the equation of the line passing through the given points. I need to, first of all, find the slope, and m is equal to y1 minus y2 over x1 minus x2. That's going to be, remember, y's on top, x is on bottom. So it's going to be -3 minus -2 over, x is on bottom, -4 minus -8. Minus minus, those turn into plus. I get a numerator of -1. I get a denominator of 4. If you used the 1's and 2's the other way, you would end up with +1 over -4. Whoops. And either way you do it, you end up with a negative fraction. So now use point slope. So y minus y1 is equal to m times x minus x1. I can pick whichever one I want. This time I'll pick that point and I'll pick that slope, mainly just to show you it doesn't matter which one I pick. So I have y minus -2 is equal to the fraction -1/4 times x minus -8. I'm going to rewrite that as y plus 2, minus minus turns to plus, is equal to, that one's plus, I'm going to go ahead and distribute that fraction. -1/4 times x is -1/4 x. -1/4 times 8, -1/4 times 8, this little work over here, put the 8 over 1, 4 goes in there once, 4 goes in there 2 times, and that is -2, so I'll put -2. Now I subtract 2 from both sides, and I get y is equal to -1/4 x minus 4. Hopefully those 3 examples are enough for you to feel comfortable with finding the equation of a line given 2 points. Remember that every time you're given 2 points, you have a two-part process. First part, find the slope. Second part, use point slope. Okay, work on that assignment.